This video presentation is a longer version of the talk I gave for the fall 2021 North Carolina section of the American Association of Physics Teachers / Zone 5 SPS meeting, which was hosted by Davidson College and Wingate University on November 13th, 2021, virtual via Zoom. The title is Publishing in the British Journal, Physics Education. I recently retired from UNCA, and I would like to talk about this wonderful journal and how you can publish in it, give you some tips, and talk about the journal and the process of publishing in that journal. This is an aerial photograph of my school. This is the quad. I was flown in an airplane by Bruce Green, a former physics student at UNCA, many years ago. Here's our library. There's the administration building, and here's the science building where physics is. Physics is pretty much in that wing right there. Now, the inspiration for this talk comes from another NCSA APT / Zone 5 SPS joint meeting held in North Carolina. This one hosted by UNC Asheville, my institution, and it was almost 20 years ago. Carl Mamola, who was then the editor of The Physics Teacher, delivered a paper called The Physics Teacher and You. He was so good at telling us about the journal and encouraging us to publish in the journal. And he also mentioned that some folks in the room had recent papers in the journal. And that brings to mind Davidson faculty members who had published recently in The Physics Teacher. And Carl served as a cheerleader, encouraging us on. And that's what I want to do, with the focus being on the British journal, Physics Education, which is kind of similar, very similar to The Physics Teacher. Here is our secretary treasurer for many years, Denise Wetley, and she is at Wake Technical Community College in Raleigh, North Carolina. And here is Conrad, known as Bo Wessel, from Wayne Community College in Goldsboro, North Carolina, who is now retired. And this is Edwin Taylor, the keynote speaker for that conference, of Taylor and Wheeler relativity fame. So here I'm going to be like Carl, but to champion everyone to publish in the journals, both Physics Teacher and Physics Education. Both are excellent journals to consider. And I'm going to focus on Physics Education, the British journal. So I put an IOP for Institute of Physics. That's the British equivalent or version or analogous organization as to our American Institute of Physics. And PED is the abbreviation for Physics Education. And I'm lazy, I do this, I just Google this, and then up comes the first choice is typically what you want. So then you click on there and you're at the journal website. This, by the way, is my living room. Bud, my office assistant at the time, is holding the tuba, and he's sitting in my living room. We had written a paper on the tuba and harmonics back in 2017. And ever since, they liked that figure. They put it on the cover, that issue, and then they've used that issue as sort of a promotional sample issue at their website ever since 2017. Now, Physics Education, just like the Physics Teacher, focuses on introductory physics. So teaching of physics in schools and colleges, and this would include high school, physics taught in high school, and typically the first year, say, of college, these introductory courses are the main focus of the journal. Now, the way the review process works, it has changed over the years. When I first submitted a paper back in 2005, I received 3 referee reports, which is typically what I've gotten from the Physics Teacher. And in that case, 2 had been favorable, 1 was not favorable, and the editor went with the favorable one. This was a bicycle paper I wrote about a bicycle accident. And I'll talk about this a little bit more later. But over the years, I've been getting in recent times, one review. What they're doing is there's an informal review, or I guess it's a formal, but it's not a thorough review, but someone inside the journal looks at the paper and decides if it should be sent out for formal review. I discovered this by accident. Once I got two referee reports, and one said merits further review. That was all it said. And the other one then was detailed review. So someone in-house looks at it and makes a decision whether it should be rejected outright or sent on. And then if it's sent on, you get a result in about a month, in less than a month. Here's an example of my paper, most recent paper, submitted last May 2021, and it's published not that much more than 2 months. June, July, it's 2 months, and then just a little bit more August. So I submitted May 26th, and then within that 4-day period or so, they looked at it and decided to send it out for formal review. And then that report came back to me in about a month's time and said minor amendments. Now, you love it when they say something like this. That means they're going to accept it. Minor amendments. That's what you want. You don't want to get the letter that says rejection. All right. So this is good. This is 1 month. So I then work hard to do the revision, quickly. They give you some time, but they do kind of push you to get it done. So it's not, you can't take like another months and months. So here I submitted that, turned that around in 1 week's time, and then they accepted it in 2 weeks' time. They sent me the proofs a week later, and then I turned that around real fast, 2 days, and then in 10 days they published it. Now they publish it first online as they're building that issue, and then when they get it finished, they then print that issue and send it out to their subscribers that are subscribing to the print version. But that's 2 months to get published. Now, to help you get a better understanding of the journal, I'm going to give you my story and my submissions and papers and topics and talk about the journal and things. And here, I hope that with these 7 guiding principles, this will help you be successful in publishing in the journal. This record I have over this period of 2005 to 2021, the record, like a win-loss record, is 33 wins, 2 losses, where the wins means acceptance and 2 means rejection, where he doesn't get published. However, what's really neat though with these journals is that if you get rejected, you can still write up a revised version and then send it to the other journal, like the physics teacher. I've done this both ways. I mean, both journals are challenging, the publishing, like one's not easier than the other. So if you get rejected in one, I've gotten rejected by the physics teacher, and then I've revised and submitted to physics education successfully. I've been rejected by physics education and revised and sent to the physics teacher and been accepted. So the idea is you get another shot. You get another shot of professional review. Okay, so let's look at the principles. The first one is co-authors. Co-authors are very, very important. They help to give an interdisciplinary flair, as you'll see by my examples. I do like to publish occasionally alone, so that when the tenure committee and committees review my work, they see that I have some solo publications. It's kind of like diversifying a stock portfolio, for example. And also, I'm an introvert. I like to be quiet at times and just scroll away and work on my own and publish a paper with the sole author. This is Mount Pisgah that we're looking at from the UNCA library. Co-authors here are faculty at home, at the home institution. We have music, we have environmental studies, biology, drama, psychology, and physics, and they're all bringing to the research another perspective, which is very, very valuable. Sometimes they contact me, like in the case of Dee here, environmental studies, and Christine in music, and sometimes I recruit. Then there's a faculty at other institutions. I met Erica through my daughter Krista. Erica and Krista had both obtained doctorates in music around the same time, and they were at a professional conference in Greensboro. And Krista says afterwards, Erica and Krista, I think she said there was a bar, and Erica grabbed a beer bottle and blow into, across the top and get four tones. She says it was very entertaining. So through Krista, Erica came to my home to work on some research. I told her to bring the flute. We do 2 papers, and we did publish 2 papers, one on the flute and one on the bottle resonances. Students at the home institution, we have here literature, art, photography, and engineering. I'm very proud of Halima here that was able to take my Physics 101, Light and Visual Phenomena, aka light, and publish by just taking one physics course. And she's not even a physics major. And then here in literature, Lydia, same thing, but by Physics 102, the physics of sound and music, not a physics major, and we published. And here, Gearson, an engineer, was able to do some cool work with a camera, technical things. So the technical aspects of the engineering that he brought to the research was very, very exciting. And that was very cool. I'll mention these again later. Okay, here we have students at other institutions. This is the son of the then social science dean. I ran into the dean at the UNCA cafeteria, told him about my publications in music with instruments, and he says his son, a physics major at Chapel Hill, plays the French horn. So when he came home for a vacation, we did some video and did a paper on the French horn. Here, this is my daughter Krista's boyfriend at the time, Willie Michel, and he was studying violin at Indiana University, a master's student. I asked him to play a Sibelius excerpt for me since I wanted to talk about the artificial harmonic trick that Sibelius used in his violin concerto. Not only did he play it, but Willie explained it very well, so I invited him to be a co-author with me, and now he is my son-in-law. Here are high school students. Here, Ethan contacted UNCA offering to work for free in the summer as an intern for the experience. I showed interest in him, and when he told me he could program, we worked on a program and published a program that he wrote, HTML5. Here, Chloe from the school, North Carolina School of Science and Mathematics. She was home one summer, and she was going to miss a research experience at her school that summer, and the school contacted UNCA asking if we had something for her research-wise, and we did. I worked with her, and we published together that summer. Here is staff, another resource. I was talking to Bud one day in the office, and I told Bud how one of the students I had took one of these inexpensive horns from medieval reenactments, had no vowels, and could get harmonics 2 to harmonic 9. In other words, got like 8 harmonics. And Bud says, I could get 20 on the tuba. And I go like, what? 20 harmonics? You mean without using the vowels? You mean just with the lip and the breath control? He says, yes. I says, then we publish. And we made the video. He came to my home, and we made one video at school. And he got 24 harmonics on one of the tubas. Amazing. Former U.S. Air Force airman, musician. And here at family, my daughter Frances on the left, creative writing major and Spanish major, working now in the field as a software engineer, helped me rewrote HTML5 program, and we'll mention those as we go along. And here Krista, doctorate in music, Indiana University, and she had gone to our UNC School of the Arts in Winston-Salem as an actually as a senior high school student and as an undergraduate. We wrote a paper on vibrato. I've noticed that folks in the performing arts will have professional photographers do portraits of them, and that's what happened in this case here with Krista on the right, and you saw Erica with the flute, earlier. In the case of Frances, she was actually on What Not to Wear. That's a TV show where you take your clothes and you throw out your clothes and they give you a whole new wardrobe. And it was the first one they did in New York. She was in New York at the time, and she got to be on What Not to Wear. So this hair was styled by Ted Gibson, a famous New York hairstylist that does models and movie stars. Here's an example of family connection where I published a paper with Patrick Fu, and he brought his son who helped us with the endoscope paper, and here he is. And we asked the journal, could we include a little picture of him with the authors? And they said, yeah, sure. So that was neat. Father, son. And here is boy, friend, girlfriend, and then later husband and wife. So when he was a student, he took pictures of Suzette here at Skierson, was a photographer engineer, and we're showing the theoretical depth of field where the print that's close up and the bricks that are far away in the theoretical pinhole camera, everything's in focus. So we did that, he did that, and then later became husband and wife. It's a love story by the time the paper was published. And we asked the journal if we could include Suzette's picture also with the authors, and they said, fine, no problem. And they went on to get bachelor's and master's in engineering. That paper to pinhole camera, by the way, was stimulated by Herb Pomfrey, a biologist, because to find the optimum pinhole size, we had to worry about the pinhole size. He said insect pins. It's well known in biology, they have well-defined diameters that you already know the diameter by buying the set. So we were able to find the ideal pinhole by trial and error with the camera, but also know what the diameter was precisely thanks to the biologist, Herb Pomfrey. There's Herb Pomfrey, now retired biology instructor. Another example is my brother Ken. When he was 7 years old, he was in a car accident riding a bike, got hit by a car. And this paper I originally sent to the physics teacher. Here's where the accident occurred. Came out of this alleyway, and I explained the surrounding context of the paper. I talked about the village with its alleys and how kids would ride bikes there. And when I submitted that to the physics teacher, they liked the paper, but the referee said, take out the town discussion, all right, have just the bare physics. Now, I'm interested in just the physics. That would attract me. But I'm thinking, I don't want to attract people to physics that are like me. I want to attract people that are different than me and different than the referee. So I wanted to tell the story. When I tell the story, I noticed that, like, my daughter Frances was more interested in physics by just telling the story, while my son would be interested in just the physics. Okay, so that's like me, all right? But we want to attract the physics people that are not like us. And so the story was important to me. So since the physics education journal is so fast, I shot the paper over to them while I was still holding my decision on how to respond to the referee. The physics education wrote back and says, yes. Actually, they had 3 reviews. 2 were positive, 1 was negative. Editor wanted to go with the positive. Back in those days, in 2005, I had the 3 reviews for that one. And the editor was concerned about one thing. And I says, oh no, what's this? Are they going to throw out the town? No, we want to make sure that your brother's okay. That your brother, in other words, we don't want to capitalize or take advantage of someone's misfortune. Is your brother okay? I wrote back and says, Ken is fine. In fact, look, why don't we can include a picture of him with me, the author. And they said, that's what they did. And also I discovered that physics education dealt with students that were less than like seniors in high school in physics, like over here in the States. And they were dealing with, like, I think 11-year-olds or something. It was like a lot younger. And one of the reviewers was teaching students like that. And he says, you got to be careful how you describe his head hitting the curb. We don't want that to be that graphic. We need to, like, rewrite that, tone that down. So I was delighted that that's what the changes were. You mean I can keep the town, I can keep the story, which is very personal to me. And I had a link to the website of this town, which is now in the Registry of Historic Towns in the U.S., built during World War I for the shipyard nearby. And the town was built on the Garden City concept developed in England I was sure to point that out in the article. So I made those changes, and this is one of my favorite papers. And my mother was involved because my mother drove the car around here where the accident occurred and could confirm what a reasonable speed was and to compare it with my reconstruction of the accident. However, Mom did not like Ken's shaving his hair off his head. She mentioned that. Here are strangers. We have a master's in physics on the left, Edwin Ball, who had beautiful software on his website, academo.org, and I asked him, could you consider revising one of those or making a variation on a spectrograph that I could use then in the laboratory and we could try to publish? And he said yes, and that's what we did. Here with Charles, I learned about this supercooled water turning into ice from my office assistant at the time, who was at the waterfalls during the really cold temperatures in January of 2018. In the Looking Glass Falls region in Pisgah National Forest, that's actually Mount Pisgah out there, and not that far away from Mount Pisgah is the waterfalls. And here, my secretary office assistant at the time had switched jobs to go work for the chancellor's office, which is very time consuming. So he had no time to work with me. So I found that Charles had also been there at Looking Glass Falls that same day and had beautiful footage, similar footage, and of the water turning into ice. He called it ice lava. So we published. The second principle is the prelude versus the symphony. You know, when you're teaching at a school like UNCA, a liberal arts school, you're consumed, all your time is consumed with teaching students and preparing for class. You don't have the luxury of, say, being a full-time graduate student where you have months and months to write a thesis, which could then take, years and then to publish years. And if you're teaching high school, it's even more time consuming than, with students and teaching more hours, contact hours and all that. So I noticed that my piano teacher at the University of Maryland would publish short articles on piano performance. So I'm thinking, hey, that's like publishing a prelude instead of a symphony. Like a prelude's like shorter to write, time to write. And also you can cash in when you're teaching. Don't undersell the time that you spend preparing laboratories, preparing lecture demonstrations, preparing lecture notes, that time should count. So all those weeks that you spend doing that, then it becomes time to write something up for physics education, which I consider to be the prelude. After all, a tenure committee at my school is going to be 2 social scientists, 2 natural scientists, may not even be a physicist, a chemist, say, and a biologist, and then 2 humanities folks. They're not going to even be reading the papers. They're going to just see if you published, all right? So here, publishing the prelude gets you the publication, and that's really ideal for someone at a school like UNC Asheville. 3, don't be afraid to publish a tweak. A lot of papers that are published in physics education, and also the physics teacher, are variations on a theme that everybody already knows. So don't be afraid to publish a tweak on something that everyone knows. For example, my most recent paper on speed, acceleration, and distance, everybody knows this, that if you have the velocity as a function of time, the slope gives you acceleration, and a little area strip's going to give you the distance traveled for that interval. Everyone knows this. So the tweak here is to use a YouTube video to get the plot of the velocity as a function of time and then go from there. Here's another example of something well known. Everybody knows about the camera obscura, the pinhole camera. It's been known for thousands of years, many publications. But when Halima showed me after class her picture, I said, we should try to submit that and see what happens. This is so beautiful, this art, this photography of the mountains, upside down mountains of western North Carolina and the city in North Carolina, and the street. So we submitted it, and the referee said, this is well known, but the presentation is compelling. Publish it. And then we luckily got moving cars. I got a video of moving cars, so I felt that there was something I hadn't seen before in a publication, the moving cars. So we published a video along with the paper. Now, the two writing rules come from my family. One's called the dad's rule, which you can refer to as the rule of static friction. There's a force that needs to get started when you want to sit down and write a paper. And I need that extra push, that force. I need some rules, some help. And Dad's rule is start by putting something on paper, anything, do not worry about it being polished. And so that gets me started. That gets me over the inertia of that. You can think of that as static friction to get things to budge. So that's my fourth tip, the first part of the fourth tip. The second one is the daughter's rule, which you can think of like kinetic friction, where you still need help. I still got resistance. I still need to keep going, but not as great of a resistance as that initial push. So daughter's rule, rule 2, daughter's rule says write draft after draft, leaving it aside for some time between drafts. I find this very valuable. We'll write a draft and then write another draft right after, and then maybe take a break, go for a walk, and then write a draft. Well, my daughter told me this rule. She said, as a creative writing major from Carnegie Mellon, she said, this is what I do. This is what I do. You think when I write something the first time, it's going to be real good? No. So she's encouraging, see, the polishing, the writing. And I remember in psychology, space practicing is very, very valuable. For example, in practicing the piano, it helps. So when you just take a break and come back, you have other insights and you can revise and polish. And here I will have something like easily over 12 or 15 drafts over a period of 4 days. And I label them all, save them all. And then after a week or so of writing, I'm ready to submit maybe draft 18 for the publication. 5, references. It's also very important to put your research within the context of other research and papers that have come before you. In one case, I found the work of Lord Rayleigh very, very relevant to current papers that were being published and I was working on. Sometimes I start my paper by framing the paper with references. I put the references down first and then write the paper according to the references. Don't fall for the perfect paper trap is tip number 6. And I almost did last summer with this paper. And I want to show you how I almost fell for this trap. But before I get into this paper, let me just mention that when I worked with James Perkins on the corrugated tube, we found, as we delved into it, how complicated it was. And then we found engineers, the same authors, publishing papers over a period of like 10, 15 years, and like their career. So at some point you want to say, here are the assumptions I'm making, here's some references, and here's what I'm not sure of, but proceed anyway. You don't want to take 20 years to write one paper. So here's how I fell for the trap with this paper. I got the data from the speedometer in the car, kilometers per hour. I translated that to meters per second, and I got this beautiful curve for the velocity every second, putting the speed down. I thought, this is cool. I love this. This is going to be nice. The idea was the YouTube, the Camaro accelerating from 0 to 300 kilometers per hour in less than a minute, 40 seconds. And then I took the little strips of area. So if you have, for example, if you have a little like rectangle here that you make, your height is your meters per second and your width is your seconds, and you multiply seconds canceling, get meters. So you get your distance, and that looked real nice. That looks real nice. See the accumulated distance traveled as the car sped up. And then what you do is you take the slopes of each interval, and that gets you the acceleration. And when I got that, I was disappointed. I felt very, very bad that I think it's a bust. I can't publish this. This doesn't look perfect and smooth like the other graphs. This looks like garbage. This looks bad. And then I thought of the idea of smoothing the data, where you take the velocity data and you average over neighboring points. And I found a site at a British institution where they did that. I thought, hey, this might be cool. Another thing for students to learn. So I picked a parameter and did some smoothing and got this beautiful graph, and then I felt I could submit. However, when I submitted, the referee didn't like it. He says, that's another complication that's going to confuse students. Go back to the original data. Now, my point is here, I almost didn't turn this paper in. If I didn't think of the smoothing, and I would have just kind of given up. But that would have been unfortunate, because then I wouldn't have published something that could have been published. So don't fall into that trap. The referee liked this, and I thought, well, what can I generate with student questions? Have you ever been in a car that accelerates and is jerky at the beginning? That can explain things like this, or maybe shifting gears and there's a jerk in the car. So other things like that. I agreed with the referee. It was better to discuss things with the original data than trying to do some smoothing and introduce another complication. The corollary is, do not reject yourself. Let the referee do that. And the referee did not reject me, but I almost rejected myself. And the last tip, and this will help give you even more information about the journal and the interdisciplinary nature of works in that journal, is from Neil Sedaka, a songwriter. Rule 7, aim for the drop-dead figure. Now, I got that from Neil's interview, where he was talking about Laughter in the Rain. This is a 1974 hit that was very, very popular in the 70s, mid-70s. And he says every song needs a drop-dead chord. He said that in an interview. And then he proceeded to show on the piano what the drop-dead chord was in Laughter in the Rain. It is the chord that goes with the words when they're singing, ooh, actually the word ooh, and then they sing, I hear laughter in the rain. So with that ooh sound is that chord. Now, all the chords are nice in a good song. All the figures are nice in a good paper. But when Neil Sedaka is saying, try to make one chord extra good. So I try to make one figure extra excellent, like the drop dead figure. And here, this is the drop dead figure. This is a beautiful picture, photograph of the art major, and that's what she brought to the research. She brought this drop dead figure and setting up the room, preparing the room for the camera obscura. And here's another example, and one which you don't have to be a professional to take. Anybody here can take this kind of a picture. I did not have any special lighting. Bud just sat down with the tuba in front of my fireplace. You can take this picture with an iPhone, all right, your cell phone. This is within reach of everyone. And look, this one made the cover, and they even used the cover in that issue to promote their journal. Here's one of a spectrogram, a physics one, where the yellow is more pronounced, and when there's more than one harmonic that's pronounced, you hear an interval, and if there's more than two, you hear a chord. And this kind of singing, the throat singing, which you find Tibetan monks, for example, work with something like this. This throat singing, very fascinating and very nice picture of what is going on. Here is my daughter singing vibrato, and the vibrato here, usually about like 5 or 6 squiggles per second. That's the rate, 5 or 6 hertz, and she's turning vibrato off. And this is kind of amusing to me, because when she was a high school student, she was making a similar thing for me with a real oscilloscope at the time. Didn't have any software like this. And I said, can you sing it without the vibrato? And she says, Dad, you can't turn vibrato off. She said, it's natural with singers. And she's correct. It is natural with singers. You don't want to hurt your voice trying to do weird stuff. But when Krista got her doctorate, she had such control of her voice that she could turn vibrato off. And I says, that's what we publish. We publish this. This is amazing. Look at that. Vibrato off, vibrato on, vibrato off. And we have a video that goes with that. This paper came during my spring break. We worked something like 8 hours a day. I put in a lot of time on this, and we were able to write the paper and get all the video done at a distance, because we weren't in the same place, in 1 week. Here is Lydia's example with synesthesia. Now, Lydia discovered that she had synesthesia. That's when you hear a sound and see a color. She discovered she had this in my class. I was explaining synesthesia to the class, and the class was confused. And Lydia's like, why are you confused? She's like wondering in her seat, what's the deal here? Like, don't y'all like see colors when you hear like vowel sounds and consonants and letters? When you hear sounds, like you see colors? So she came up to me after class, somewhat shaken, saying, I just discovered in your class that I have something, I'm different. I have something that very few people have. And I said, this is a wonderful story. And you're a creative writing major. I think I asked her at the time, what's your major? She said, creative writing. I said, oh, we write this up. This would be a good story. So we wrote that up and it got accepted. And this paper, I think, was a front line. It was like a short paper that was like 900 words or less, very short. And the journal picked it out. The editors picked it out as a highlight at the end of the year. I don't think they do the highlights anymore, but the camera obscurable with Halima's picture on the wall, and this one became highlights the years that they were published. So this figure is a fascinating figure. It was the only figure in the paper. This showed how Lydia sees color for each letter, the colors associated with each letter. Now, this one is a professional photograph by Zach Catanzaretti, and I found this one on Flickr. Flickr will have the copyright next to each photo work up there, and some say all rights reserved, some say some rights reserved. So this one had some rights reserved. It gave me confidence, so I contacted Zach, and Zach said I could use it. And this was my drop dead figure for the paper with the camera accelerating from 0 to 300 kilometers per hour in less than a minute. Here's a rocket paper I wrote with James Perkins and Ben Cooper over here. Photographer, wonderful stuff, and so friendly when I contacted him. And actually, he wasn't the first I contacted. I remember contacting some. You get rejections. Sometimes the photographer doesn't want to, share the picture. That's okay. Just keep going. Don't let that discourage you. And when I got to Ben Cooper, this is really the one I wanted to use. And Ben said, no problem. To show some thanks to Ben, I bought his autographed book of photographs so I could give it. I bought 4 to give it to my relatives as presents and kept one for myself. Beautiful picture, a drop dead figure. Here is a series of pictures from a solar eclipse, the 2017 one. I went to Greenville, South Carolina. Actually, my pilot, Bruce Green, flew me there, and he's there with his girlfriend, and he got to see it too. And I got to make this publication. I got this idea back in the 70s when Professor David Falk was showing about 6 slides taken by his colleague, Dr. Goldberg, who had gone to Mexico for a total eclipse in 1970 and set the camera on a constant exposure, light sensitivity level, and then took pictures as things got darker and darker. These actually are stills from the video. So half a century later, that idea was still with me, and I took it to the next level with taking a video with the exposure, set constant so it wouldn't be no automatic change of the exposure, and got this sequence. Here is damaged retina. This photograph was given to me by Dr. Mark Clark, and the photograph was taken by his colleague and ophthalmologist, Dr. Charles Hunter, in Anderson, South Carolina, back in 1979. And this is the damage, the little white region here, because the fovea here should be dark, less blood vessels, but that white spot is showing there's damage. This is the optic nerve that goes off the brain. Myelin sheathing looks yellow. It's like insulation to a wire. And here, they told me, Dr. Mark Clark said, basically they thought it was a thermal burn, the standard magnifying glass effect where the sun rays meet at a point that's then can burn paper, for example, and here a thermal burn on the retina. But when I researched this in more recent times, the doctor said there's something even more important and more dangerous than the thermal effects, and that is the photochemical permanent damage. When you see a bright light, you then see an after image that's dark for a little while until your eyes can recover. But in this case, by looking at the sun, the eyes don't recover. Like you damage the photochemical reaction like permanently. And the papers, and they're referenced in the paper that I wrote, basically indicate that is more a severe case. This paper, by the way, was rejected by the physics teacher because I had been a little too cavalier with the thermal aspects, as that publication said, and I have to agree with the referee. You never want to be cavalier when there's possible retinal damage. So I agree with the rejection. Carl Momola was very kind. He wrote me a personal note as gently as he could, saying the decision was final. But as soon as he told me it was rejected, I knew I could fix it, but I couldn't send it back to the physics teacher. So here's a good example where you have another shot. So I rewrote it, making it very, very serious paper about the dangers of the sun, and physics education accepted it. I learned from that rejection, rewrote the paper, and it was accepted by another journal. Here is the vanishing fence trick. I remember a faculty member's wife at a social asking me about why the fence disappears when she's taking a picture of an animal farther away, and I had a picture of an owl that I took at a zoo that had a similar effect, which I showed for years. But then when I was on vacation, not too long ago, a few years back, I noticed I could zoom in and that fence was so dramatically disappeared. I could capture some video and like zoom in and like show the gradual elimination of the fence. So I wrote a paper here with the vanishing fence. Look at that. That's in front of the bongo there. But look, you don't see it at all here. It's amazing. So that's a cool physics application with photography. Here is Looking Glass Falls in Pisgah National Forest. I saw Mount Pisgah earlier from the UNCA campus, the library. I was here yesterday. I took a friend from New Jersey who I went to grammar school with, I hadn't seen in 60 years, and we went to the waterfall. Now, when it got freezing that January in 2018, we got this. This is amazing. Look at that. And the super cooled water was flowing, turning into ice right before our very eyes. And this was captured January 7, 2018. And look at this graph. This is sort of a drop dead figure. Here is freezing, up here is 0. And this is like midnight, 1 o'clock in the morning, 2 o'clock in the morning. Look how cold this is. And then right about here when the videos were taken, like at 9, 10 o'clock, this is the water flowing, super cooled water flowing, turning into frazzle ice, which my colleague and co-author Charles Cranford referred to as lava ice. Here is software. We talked about software earlier, and this is a Fourier synthesizer. I wrote HTML5, and the time is ripe, still ripe, to translate old programs that were written in Java and in Flash for security purposes. They don't have Java and Flash anymore in terms of the internet and accessing them. So you want to write things in HTML5. And the Davidson effort is a very good example here because they're award-winning Physlists that date back many years. Wolfgang Christian and Mario Belloni working on those. They have rewritten those in HTML5. So it's very ripe for students that know computer programming to take some old program that still was still in Flash or Java, never got translated, and do a translation and publish it. Here's another example. This is the spectrograph, and these are spectrograms made by the spectrograph. This is a thermin showing the spectrogram of a thermin, and this is a screen showing the spectrogram of a screen. Here's another example, and this one with Edward Bull in England and Frances, my daughter, and these are oscilloscope examples. This is cool. This HTML5 can be delivered over the internet. You can access it at my website. Here's a flute played by Isabel, one of my students. Look at that beautiful waveform, and you can measure the period and the frequency from it. There's the milliseconds. And here you have the French horn, the Chapel Hill student I told you about earlier who co-authored a paper with me. Look at that, beautiful example of the French horn. And you can choose files, you can talk into a microphone. There's all kinds of cool effects there. Here's the high school student paper where we published something that everyone knows. Everyone knows that if you have a bead that goes around a circle, that you take the projection along the y-axis, or for that matter, the x-axis, and you get a sinusoidal wave that gets shaken off. So as this bead goes around, this goes up and down, and then you shake off that sine wave, and you can pick different wavelengths, you can pick different amplitudes, and you can drag around the ruler. You have a whole laboratory that you can do with this equipment delivered over the internet and written by a high school student working with me. Here is the monster tube, and this monster tube is very, very dramatic demonstration. And I now want to go into the concept of the video abstract. There is the video of the professor, that's me, getting very, very dizzy, reaching harmonic 6. I did get harmonic 7 for a brief moment, and physics education introduced me to the video abstract. They say when you submit your paper, think of doing a 4-minute video abstract describing what you've done, and that helps to give the reviewers insight within 4 minutes of what your paper is all about. And I think it helps get you published. So I recommend the video abstract to go with the paper. Here's the dancers. We're dancing the longitudinal wave in class. I have a big class and got a lot of students involved, come up front, hold hands, and we go back and forth. And some students to our nodes here, and there's an anti-node when you can demonstrate all this cool stuff in front of the class in a very dramatic fashion. And there's a video that goes along with that. Here is a paper that had, the idea came from 2 grammar school students. Back in the 1980s, I took a toy corrugated tube, and it was at a Thanksgiving dinner at my colleague's house, John Stevens, chemistry professor, and his kids took the thing in the other room, stuck it on a vacuum cleaner, and they turned it on. It had a very, very shrill sound. When they turned it off, it went beep, 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 beep. You hear about 12 harmonics. Wonderful. So I published this decades later, giving them credit. And here, Rob Burles from the drama department, he does sets. He has all kinds of equipment, man. He had all kinds of vacuum cleaners and things. So he helped me do it. And we have to have earplugs here because this is very, very loud, shrilling sound. So everyone in the class, we passed out the earplugs, they put them on, and we did the experiment that the grade school kids did. And I referenced them in the paper to give them a credit line. And here, when Rob got closer and farther away, he could isolate the harmonics one by one. We got 12 harmonics. A very, very cool demonstration published that the idea came from grade school students. Here is an idea that came from a college student, Chris Mathis. There he is now. Back in 1979, many years ago, he majored in physics and drama. I think the only drama-physics combination we've had. And the story behind this is that when I was a grad student at the University of Maryland, I was working with Dr. David Falk, and he told me to wrap a towel around a bulb and break it to prepare it for class, but keep the filament intact. Now, we don't use incandescent light bulbs anymore. But then he wanted to show that the oxygen would cause it to burn up. So that's why they had to have like the vacuum situation. So I came to UNCI, I asked a student, Chris was down the hall there. I said, Chris, because I figured I'm the professor now, I can have someone else do this. I said, wrap a towel around this or something, break this, and then give me the filament intact. And Chris says, I will not only give you the filament intact, I will give you the bulb intact. I go, what? And he did. He taped the Scotch tape on top of here, all over the place, bits of Scotch tape all over the place, and these 2 students are going to help me do that. Actually, I'm asking them to do it and have someone else check. And then with vice grip pliers, I can, clip this at the bottom here, pressure-wise, and then pull off the bulb intact, and the filament's intact. Wonderful. We could do the entire experiment and demonstration in class from beginning to end. So that made for a great video abstract, and that one got accepted. Here's the high school student, and here we wanted to publish a paper. And first thing we were doing with oscillations on a car didn't work or something, trying to shock absorbers. So I contributed to the research, less than $20, my own money, at Amazon.com, and got these toys, beads. And then here, I wanted to do the 1 bead. You see, we're doing various numbers, but 1 bead is the regular pendulum, and then all the beads would be like the rigid rod. Well, we found out this thing was wiggling. It wasn't really a rigid rod, and it deviated from the rigid rod formula. So I delved into research, and it was good that Chloe saw me do this, because this is like research, it confuses the research. You got to think and delve into the research. And I found a book by Lamb, 1910, that had a formula with a hanging chain. And the hanging chain formula fixed the results that we were seeing. And then at the other end, the 1 bob and the string, that wasn't quite working either. And James Perkins came into the room at that time. He says, That's so light, that little bob. I think your string mass is going to have to be taken into consideration. Here, let me show you my special scale, my experimental lab here you could use. And we did that and found indeed that the string mass could not be neglected, and that fixed the other end. So that was really a cool discovery for me and great for Chloe to work with me on this, working through this research. And since Chloe hadn't had calculus, it was a lot of fun for me to derive all formulas using sums, discrete sums. Very, very cool teaching experience for both of us. Here's an example of a piece of music that was written using wine glasses with water in it to get the tuning just right. And it's such a beautiful piece of music. Well, I hope that these have been helpful to you. You'll find a few tricks here and there. I hope this helps give you a better idea of what physics education is all about, that journal, what things that they like to have published in there. And I wish you the best of luck in writing papers. I encourage you to write papers, take some photos, prepare some nice graphs, and publish, submit papers to both physics education and the physics teacher. I confess that physics education has attracted me more in recent times because I can get published in 2 months, and that is really a short period of time. Good luck and have fun reading papers, watching video abstracts, and playing with online software.